Hello everyone, my name is Amajaro Dupada. Firstly, I thank you all for watching this video. And straight away in this session, I'm going to deal with some basic terminology about the engineering mathematics. Especially the syllabus that I'm going to cover is called as Mathematics 1 from Andhra Pradesh state syllabus. Because I have chosen this one because there are many students flunked in this particular subject. There are many reasons as there are number of students who got failed in this particular subject. But I would like to mention a few reasons about the students failed in this subject. Firstly, the first reason is lack of basics in the student. The second thing is lack of right approach. The third one is generally in the present scenario, the students are not having that much interrelation with the nature, because we can understand many things from the nature itself. Even though whether it is mathematics or physics or chemistry, whatever, we generally consider them as a science. So there are many basic terms that are obligatory to understand this particular mathematics 1 syllabus. But I'm going to deal with a few fundamental basic terminology in this session so that you can understand mathematics 1 very easily. In this terminology, the first one is variables. So variable means the value which is varying over a time period or over a space. So in this, generally there are two types of variables are there. One is independent. Second one is dependent. So the name itself, independent, is nothing but the variable which generally does not depend on anyone. In the universe we are living, time t we generally called as independent variable because we all depend on time t, but time generally will not depend on us. So generally I take t as the independent variable, and let us say dependent variable means the variable which depends on a particular another variable, let us say time. So here I am taking y as dependent variable. So how we say generally dependent or independent, like let us say y I am taking as a function of t square plus 2, like in this case when time is changing then automatically y will change. It means y is depending on time t. So here t is independent variable, y is dependent variable. So generally in the differentiation, I'm not giving much about the differentiation here, but we generally represent dy over dt. This I can also say like d by dt on y. It means here y is changing with respect to time t. Then how much the y is changing with respect to time t can be calculated by using this difference. Here constants also can be classified as two types. One is real constant, second one is arbitrary constant. So both are constants, but coming to real constant, the constant which is constant everywhere with respect to time and with respect to space, then it is called a real constant. Let us say the value of a good, value of a good is 100 rupees. in India, or suppose in America, in Africa, in all other countries, if the value is 100 rupees only, then spatially it is a real constant. It means it is constant over any space on the earth. And I take what is arbitrary constant then. This is also a constant, but it is arbitrary. It means it's a changing constant. Let me have an example to understand arbitrary constant. So arbitrary constant means, let us say, let us take a space. A space is divided into 5 blocks. Block 1, block 2, block 3, block 4, block 5 like that. Let us say a constant K have value 10 in the block 1, 20 in the block 2, 30 in the block 3, 40 in the block 4, 50 in the block 5. It means under each block, it is a real constant. In the block 1, K is equal to 10 is real constant. But over a space of having 5 blocks, the K is arbitrary constant. It means it is constant, but it is changing. So such constants generally called as arbitrary. Generally, equations also classified as algebraic equations and transcendental equations. Algebraic equations are generally simple and easy to solve. There is, big methods are not required to solve them, like as we have seen polynomial equations. Polynomial equations of any degree, first degree, second degree, third degree, these are very simple to solve. Such equations we generally called as algebraic equations. Let us say x plus 2 is equal to 3. Then simply I can solve this equation. In this algebraic equation of first degree, x is equal to 3 minus 2. So x is equal to 1. I can easily solve this equation. Such equations generally maybe any order can be called as algebraic equations. The second thing is coming to transcendental equations. I just give an example here. So transcendental equations means the equations are involved with the logarithmic terms, exponential terms, and cosinusoidal terms. It means if the equation having this type of terms, then we generally called as transcendental equations. But coming to solving this type of transcendental equations, these are generally difficult in comparison with the algebraic equations. Let us say a function f of xy. If you are able to write the given function in this form, x power n into f of some constants y over x, then the given function can be called as homogeneous function. Here f is the function, x comma y are independent variables, and f is the function depending on x and y. Maybe you can take 3 variables also, f of x comma y comma z. If this function able to write x power n into f of some constant y over x, z over x, like this function, then in this case f also can be called as homogeneous function. In the first case, f is homogeneous function of degree n. Here also in the second case, f is homogeneous function in x of degree n. Sometimes homogeneous function can be called as called in terms of y and degree n also we can call. Let us say f of x comma y is equal to y power n into f of 1 comma x over y. Then this is homogeneous function of degree n in terms of y we call. Let us have another example to understand homogeneous function. Let us say f of x comma y is equal to x cube plus y cube by x plus y. Now I am taking common in the numerator x cube. Then automatically 1 plus y by x whole cube over x I am taking common in the denominator 1 plus y over x. Now 1x will cancel, then automatically x square will remain. Remaining the whole function I can say like f of some constant and y over x terms like. It means now I can say f of xy is homogeneous of degree 2 in terms of x. That is what we generally call homogeneous function. Trajectory means a path taken by a curve or family of curves. If I take a simple curve, let us say y is equal to e power x. The path taken by this function y is called a trajectory. Sometimes let us have, there are some flux, water flux or heat flux, whatever the flux, it will have a family of curves. So the family of curves will follow a particular pattern. Then that also can be called as trajectories. Maybe some other family may have like this. This is also its own trajectory. These are generally trajectories. But now coming to orthogonality and what is orthogonal trajectories. This is important. Ortho means generally to make straighten. Gonal means you know that angles. When the two family of curves, let us say f is one family of curves and g is another family of curves, or you can say individual curves also. If they interact at 90 degrees or if they meet at 90 degrees, then we can call as they are orthogonal. Let us say f family curves are like this and g family curves are like this, and if they meet, they both meet at 90 degrees between each other, then we can say the f and g are orthogonal. This is what actually orthogonality means. And trajectory means path taken by a curve, an individual curve, or a family of curves. Operator is a device. Operator is a device that is ready to operate on a particular function that we have given, nothing but input. So if we have given any input to this operator and it will do some operation and finally it will give some product. So there are many operators are there in mathematics, like sigma is an operator, pi is an operator, and nabla, you know that. So del change we call, this is an operator. Del dot divergency operator, del cross curl operator, a Christoffel is an operator. These are like many operators are there and they operate on a particular input that we have given and finally they will produce some product. This is what an operator means in general. Now we go to talk about differential operator. Differential operator, in order to understand, we should know exactly what is dependent and independent variable that we have already talked about. Once again, I am telling you, independent variable is a variable that will not depend on anything. Dependent variable means variable that depends on that particular independent variable. So in this case, coming to differential operator, we generally represent with the d by dt, or can be represented as d also. This is what general differential operator. This differential operator generally will operate on a particular function, and it will give change of a function with respect to time. So here function is the input I am giving. D by dt is an operator that is doing some operation on this function, and it will give finally output is change of that function with respect to the independent variable time. So here this function y, whatever the function it is called dependent variable, which is depending upon time t. So let me take y as a function. Let us say t square. So now d by dt is an operator that is ready to operate on t square time squared. Then automatically we will get 2t. We know that a basic formula d by dx over operating on x power n will give answer like n into x to the power n minus 1. Based on this formula, I am writing d by dt of t square is equal to 2t. But what exactly the change of function y over time t and how it is happening? In order to understand that, we have to understand first what is a Taylor theorem or Taylor series. From that, what is a limit, and then we can understand what is this differential operator. Nothing but change of something, nothing but slope also we can mention. In order to understand this differential operator d by dt or d by dx, here one more thing, like here I operated like dy by dt. I also can represent like any way I can represent, or I can say dx by dt, I can say, or I can say dy by dx, or I can say dx by dy. Like this, any way, any manner I can write. In the first case, y is function of time, and d by dt is an operator, is operating on y. It means I am going to find change of y with respect to time t. In the third case, I am trying to find the change of y over x. In the fourth case, x is dependent variable, y is independent variable. Now I am trying to identify two limits to differential operator. Now, generally Taylor is the one who found the series to express any function is f of x plus h is equal to f of x plus h over 1 factorial into f dash x plus x squared by 2 factorial into f double dash x, and so on, h power n by n factorial f of x plus theta h, and so on. See, if I write this Taylor series up to this function only, up to n, then we can say it is Taylor theorem. When you mention series, it should continue forever. It means it lasts up to infinity. Then I can say that it is a Taylor series. Now, in this Taylor series, if h is very, very small, then h square I can neglect. So h square, h cube, from this onwards, I am going to neglect all these terms. Then I am going to write this portion only. In that case, f of x plus h is equal to f of x plus h into f dash x. So now from this, I can write like f dash x is equal to f of x plus h minus f of x over h. This is what actually differential operator is. Here f dash x I can represent d by dx is an operator, change operator, is operating on f, nothing but df by dx. As I mentioned earlier, like dx by dt, dy by dt. This is what exactly limits concept also. I will write that equation in the next. So f dash x is equal to df by dx, nothing but d by dx is an operator operating on f, is equal to limit h tends to 0 f of x plus h minus f of x over h. To understand this, I am going to give a graph so that it will be easy. Let us say there is a function which is changing like this. Now, this function at the point x, the value of that function is f of x. At x plus h, it means after some step h, at x plus h value, the value of the function is f of x plus h. Now, what I want to identify the change of f over x, nothing but I want to find d by dx of f is equal to, it's nothing but it's a slope. It means y2 minus y1 by x2 minus x1. You know that here the value, here the point is x comma f of x. Here the point is x plus h comma f of x plus h. If you find slope y2 minus y1 by x2 minus x1, f of x plus h minus f of x by x plus h minus x. It means finally you will get like f of x plus h minus f of x over h. This is what generally a differentiation is, or differential operator is. So from Taylor theorem to limits to derivative, this is the fundamental formula for the differentiation. Now the same fundamental formula differentiation that I'm going to explain by taking an example that we already have taken, differentiation of T square. Basic formula f dash t I can write like f of t plus delta t minus f of t over delta t. Like this I can write. Now I want, if f of t is equal to t square, then f dash t is equal to f of t plus delta t. It means t square means t plus delta t whole square minus f of t minus t square over delta t. If you expand the numerator, you will get like t square plus delta t whole square plus 2t delta t minus t square. This t square will cancel, over delta t will remain. If you take common delta t, you will get delta t plus 2t over delta t. This will cancel. Delta t is very small, so that I neglect this delta t part. So finally my answer is 2t. This way we can identify exactly what is a differential operator is. An equation which is consisting of differentials or differential coefficients or differential operators is called a differential equation. So generally we know that actually what already differential operators are, like dy by dx is a differential operator. D by dx is operating on y. So dy by dx plus 2y is equal to some x. So this is a differential equation, because in this differential coefficients are there, or differential operators are there. So in this differential equation, we need to understand two parameters. They are very important. They are order and degree. Order means the highest order in the differential equation is called order. Highest order that exists in the differential equation is called order. Degree means the power to the highest order differential coefficient is called degree. Order means highest order that exists. Degree means power to the highest order. Power to the highest order. But one condition here, first we need to understand what is the order, and one more condition is like when you are going to identify order and degree of particular differential equation, the equation should not have any p by q terms or radicals. You have to remove it. So now let us see what is order and degree. Order means how many times you are differentiating. Let us say if I say d by dx is an operator operating on y, it means it is one time it is operating, so order is 1. First, suppose if I operate d by dx on one more time on that function, then it is called d square y by dx square. It means here order is 2, here order is 1. If I operate d by dx 3 times, on a particular function y, then it is called d cube y by dx cube. It means order is 3. Like that, the order concept will be there. Now, I take a differential equation to understand order and degree together. Let us say d cube y by dx cube whole square plus d square y by dx square whole square plus 3y is equal to e power x. In this, if you see, I want to identify order and degree. So in the given equation, the highest order is here 2, here it is 1, here it is 3, and here it is 2. It means highest order is 3, and power to the highest order is 2. It means order is 3, degree is 2. I take another example. D square y by d t square whole to the power 3 by 2 plus y is equal to 0. If you directly see the equation, order is, you can identify easily, that is called 2, but it has some p by q terms, nothing but radicals. I mentioned already, you have to remove all radicals from the given equation before finding order and degree of the particular differential equation. So to remove that radical, what I do is, I do d square y by dx square whole power 3 by 2 is equal to minus y. Both sides you can do square, then automatically you will get d square y by dx square whole cube is equal to y square. Now the equation does not have any radicals. Now order is 2. Now order is 2. Degree is power to the highest order. So degree is 3. So this is the easy approach to understand order and degree of a particular differential equation. Derivatives nothing but differentials or differential operators or differential coefficients, anything you can say. Here also the same concept it will come once again, that is dependent variable and independent variable. Let us say there is a function f is function of x only. There is another function, let us say G is function of two variables. Now I want to find change of f and I want to find change of g simultaneously. Now in order to find change of f, I can operate derivative or differential operator. We know that d I am operating on f, nothing but d by dx is operating on f. It means d by dx is an operator, differential operator is operating on function f, because f is having only one independent parameter or variable, one independent variable, that is equal to x. So in this case, we generally call it as derivative. When it is partial derivative, generally partial, the name itself it is showing like you are differentiating or you are going to find the change partially. It means not fully. Let us say I want to find the change of g over x or over y or over x and y. Let us say I want to find dg. This I can say like dou g by dou x into dx. If here, if the change is with respect to x only, but remember g is the function which is changing even if you change x or y, because g is depending on two independent variables in this case. So I can find the g change of g this way also, dou g by dou y over dy, or I can together I can find the whole change, dou g by dou x into dx plus dou g by dou y into dy. This is what actually partial derivative is. In the first case, here with respect to x I am going to find the change of g. In the second case, I am going to find the change of g with respect to y. It means in the first case, when you are going to find the change of g with respect to x, y we treat generally as constant. Here in the second case, when you find the change of g with respect to y, we treat x is constant. Together is the whole derivative. That's why generally it is called as partial derivatives, because simultaneously we cannot identify the change when two variables are changing together. That's why we call it as a partial derivative. And in the partial derivatives, function may be having many independent variables like x, comma y, comma z, comma t, like that many number of variables. So the fundamental difference between derivatives and partial derivatives is the fundamental difference between derivative and partial derivatives is here only one independent variable. In this case, in the partial derivatives, the function is having more than one dependent variable, more than one independent variable. It means 2, 3, 4, 5 and any. A system to be called as linear, it has to exhibit homogeneity and additivity. We will see what is homogeneity and additivity so that we can understand linearity easily. So let me take a system as an example to understand this linearity. Generally, any system we represent with closed box. So here definitely there will be an input something, and when you have given some input to the system, you will automatically have some output. Let us say here I am giving x1 as an input. I get output as y1. In the next time, I have given k1 into x1 as an input. It means I multiplied input with k1. If I get k1 multiplied the output y1, and in another case I tell you, so in this case, if x1 leads to output y1, and if k1 x1 leads to output k1 y1, then it is exhibiting homogeneity. It means, let us say, the same system I am giving input as x2. I get some output y2. If I give k2 into x2 as an input, I should get output as k2 multiplied by y2. It means this also exhibiting homogeneity. Now, what is linearity then? So, for the same system, if we give inputs together, then let us say there is a system. You are giving input now as k1x1 plus k2x2 together. In that case, if you get an output as k1y1 plus k2y2, then the system is called linear because it is exhibiting additivity. So finally, any system to be called as linear, it has to satisfy two fundamentals like homogeneity and additivity. Then the system can be called as linear. ODE means ordinary differential equations versus linear differential equations, LDEs of higher order. We know already differential equation, an equation consisting of differentials or differential coefficients or differential operators. Now, ordinary differential equation means simply I can say if the differential equation dE is having order 1, so linearity, we have seen what is linearity already. Linear means, so linear differential equations of higher order means, here in the linear differential equations of higher order, here order is more than 1 and it is linear. So here to understand this linear differential equations of higher order, once again we need to go to understand this what linear concept is. So I just given examples for each one. If you take ODE, it is like dx by dt plus 2x is equal to e power t. This is the differential equation of having order 1 and degree also 1 in this case, and x is the dependent variable, t is the independent variable. So a generalized equation to represent linear differential equation is d power n over of y over dx power n plus d1 into d for n y n minus 1 over d plus and so on dn y is equal to x. Here p1, p2, p3 and so on are function of x. Functions of x. And linear differential equation, see, this differential equation, nothing but it's linear and it is having higher order n. The same LDE can be represented as in another way, d power n y over dx power n plus k1 into d power n minus 1 y over dx power n minus 1 plus k2 into d power n minus 2 over y dx power n minus 2 plus and so on kn y is equal to x. Here k1 comma k2 and so on kn are constants. See, in order to understand this linear differential equations of higher order, now I am going to explain how we are calling this function as linear and what is the input and what is the output and what is the dependent variable and what is the independent variable. All concepts will come together in the next slide. If we understand these 5 terms in this equation, we can understand any differential equation and any sort of system we can understand very easily. Now, here independent variable is the denominator which is having x. Why? Because x will not depend on y, but y is depending on x. That's why we generally call x as an independent variable. Now, y is depending on x, so y is dependent variable. Now, what is input? Here, whatever the term which is having right side of the equation is called as input. Then what is the output y? Actually, the term, the value of y in the system we obtained in terms of x is output here. Nothing but a solution of the differential equation. It means because actually this whole system is telling about how the parameter y is changing with respect to independent variable x. So finally, our solution of the differential equation should be y in terms of x. So y of x is the solution. And the whole differential equation together is called as a system. This system is linear. Why I am telling here it is linear concept? Because it has 2 different inputs. It means the system has 2 different inputs every time. Any system you can consider, physically, mathematically, in any science, we generally take 2 types of inputs of the system and we get 2 types of the output. In that case, if the system is linear, how can we add these 2 inputs in the input side and how we can add the 2 outputs in the output side? That we will see in the next slide. Let us say there is a system. Which is giving output. Even though your input is 0. This is mathematically we called as CF or complementary function. In scientifically, in science, we call it as like zero input response. Or natural response. It means there is a system. I'm not giving any input to that system, but still it is giving some output. So that type of output is called as complementary function or zero input response or natural response. Let us say for the same system, I have given some input. forcibly. In that case also I will get some output. This output generally in mathematics we call as PI, or particular integral. Or zero state response in science. Or forced input response. It means in order to understand the system's response, you have to find two different types of input responses together. If I add zero input and forced input together, then I can add outputs also, zero input output and forced input output. Then the system can be called as linear. So in this linear differential equation, we finally find of any system, the response we find as complementary function plus particular integral. It means for two inputs like zero input plus forced input. It means two types of solutions you will identify, and at the end you have to combine the two responses together, then only the whole response of the system you can obtain. But here we may get doubt, like even though input is zero, how we are getting that output? That is generally happening due to the storage in the system. That storage makes the system non-linear. In that case only generally we get differential terms or differential operators or differential coefficients. So in that case we generally get some output even though our input is zero, because of storage, or we can say like memory. That's why whenever there is a storage or memory terms comes, automatically we get differential equations, nothing but non-linear equations. This is generally happening, this topics comes like in almost all engineering subjects. Like this is the reason behind it. So we should be very clear about these two types of output. Maxima and minima of a particular function can be defined as the extremities of the function it is reaching. Let us have an example. Let us say the function is varying like this. It has many extremes, like here there is an extreme point, here extreme point, here also extreme point. It is a valley like T valley, like that. Many extremes will be there. So generally there are many maximas and many minimas are there. Generally in that case we call local maxima, local minima, global maxima, global minimum. Global means all together at the end final value of maximum. Global minimum means the ultimate minimum. So generally we have seen the same concept like in real constant and arbitrary constant. Real constant is like a global constant. It means irrespective of time and irrespective of space, it is constant. But arbitrary constant is, it's like local constant. It means in a particular time or in a particular period or in a particular space, it is constant. And once it is crossing that boundary, then it will change. That's why it is like changing constant. Here also like that only, global and local maxima and minima will happen. But how it is like, is how this maxima and minima is interlinked with this differential operators or differential equations like. So here f is the function which is changing with respect to x. It means I can apply dy dx is an operator, change operator on f to find the change of f with respect to x. If you see here slowly the function is rising, it means function slope is rising. It means this angle generally we can call it as acute angle. For suppose in this case slowly it is coming down and slope is negative. It is called obtuse angle. Because in the case of acute angle, the slope is positive, like m, nothing but slope is positive. Slope is rising, 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 rising. At one point, it reaches extreme point. So here, the slope becomes 0. It means at this point, df by dx becomes 0. Again, slope is coming, function is coming down, decreasing, and slope is negative in this case. And finally, it reaches another extreme. Here also slope df by dx becomes 0. Because at this point, change of f with respect to x is 0. It means at extremes, df by dx becomes 0. That's why to find these extreme points, let us say x1, x2, x3, and so on, we have to make df by dx is equal to 0. Then automatically you will get x1, x2, x3, like arbitrary points when you make it equal to 0. Now, we have to identify where the function will become maximum and where the function will become minimum. That is important to identify. And before that, we can say this is concavity and this is convexity, and where it has equal values, this is inflection. This is called point of concavity. This is the point of convexity. This point where the function having two equal values, there it is. So how to identify that? When you make df by dx is equal to 0, then you get arbitrary points like this. Now at x1 and x2 at x3, the function may be maximum, may be minimum. That we have to identify. I draw the figure once again. Let me take this point. I got this value, let us say x3. Now at x3, it may be maximum, it may be minimum, I don't know. Because I got these values only, like x1, x2, x3. Now I want to identify whether f of x is maximum or minimum or peak or valley at x3. Now you take some value before x3 and you take some value after x3. It means x3 minus something value, x3 plus something value. Here you can find slope, let us say m1, nothing but df by dx. Here you find slope m2, nothing but df by dx at that particular point. If m1 is positive and m2 is negative, it means before it is rising, after that it is decreasing. It means coming down. It means it is a peak. It means it is maximum. If m1 is negative, see in this case, here you will get slope negative, here you will get positive. It means if m1 is negative and m2 is positive, then here you will get a valley. It means a minimum. So this way we can identify. There are another techniques to identify at a particular point the function is maximum or not by finding second order differentiation. Nothing but you can find d square f by dx square. If it is greater than 0 at that particular value, at that x, if it is greater than 0, it is a valley. If it is less than 0, it is a peak. So you can apply these are the techniques to identify the maximum and minimum easily.